So in today's Onshape step-by-step tutorial, we're gonna do a full end-to-end project. We're gonna start out with an idea, we're gonna turn that idea into a PartStudio, we're gonna take the parts and add them to an assembly, and then we're even gonna create a 2D drawing, or really a set of 2D drawings, to create a cut list for this prototype. So we're going to actually be creating multiple 2D drawings and showing the power of 2D drawings, even in this modern age where everything is a 3D model. And so that end-to-end project is very typical of what you do in the world of prototyping. You kind of come up with a brainstorm, come up with an idea, and then you just want to get something out onto the shop floor so you can start cutting parts and kind of see how those parts fit together in your prototype. So the prototype that we're going to be building today is going to be this. This is what's called a Soccer Rebounder, and a Soccer Rebounder is typically made out of wood, and it exists in 3 different states. So in its first state, it is setting flat so that you can pass back and forth against the wall and just do straight passes. Then you should have the ability to take the whole thing and flip it over. That creates about a 60-degree angle, and that way when you pass, you can practice fielding the ball out of the air. Now, just quick disclaimer here, I am not a professional soccer player. I built this for my roommate, and he is a much better player than I am. Finally, in its third state, these legs need to collapse, and that way you can easily transport this rebounder and you can store this rebounder. And by the way, you might recognize those locking hinges. It's this device here, the 90-degree locking hinge that we saw here in an earlier tutorial on the Onshape YouTube channel. So if you want to see how to model these parts out of sheet metal, be sure to check out that tutorial as well. And so when you're done with today's tutorial, you'll see all the steps that are required to build this Soccer Rebounder. And maybe that's what you want to do. Maybe you've got a roommate or you've got a niece or a nephew and you want to build a Soccer Rebounder for them. That's great. You know, it makes for a great gift. It's an awesome device, very helpful for practice. But of course, you could extrapolate the information from this lesson and apply it to any prototyping process. So what we're going to be learning is how to come up with an idea, how to start modeling up parts in the PartStudio, how to put those parts into an assembly. We're going to do a little bit of assembly motion to do some validation. We're going to work with a what's called a variable studio to help with setting up the sizes for this project. And then we're going to take the components from that assembly. We're going to add them to a drawing. We're going to make a bill of materials, and we're going to make multiple sheets so that we can kick off cut lists for the individual components. And if that all sounds good to you, then you are in the right place. Be sure to hit the like button on this video, and let's get into the first lesson in today's Onshape step-by-step tutorial. All right, so this is the project we're going to be working on, the Soccer Rebounder project. You can see here that we've got a PartStudio, and then we've got an assembly. Actually, let me move this tab over a little so you can see this. Here we go. So down at the bottom here, you can see that I'm on the tab for the PartStudio, the wood parts. We've got the assembly tab, the drawings tab, and then the variable studio. So the assembly here you can see what these components look like when they're put together. We've got a drawing, including a bill of materials, and we've got a variable studio. So these are going to be the things that we set up here as we go through the project. And this version of the project is actually available in the public space. So if you go into the public space here and you search for, let's see here, so we go into public and you search for Toby, you could probably just search for Toby Soccer, honestly. Soccer, let's see what we come up with. There it is. Toby 2025 Soccer Rebounder. So if you want to take a look at the completed project, if that helps you to follow along, or if you want to make a copy of it so that you can build a rebounder, you are welcome to do so. You can just search there in the public space. But what I'm going to do for this project, and what I'm going to have all of you do right along with me here, is choose to create a new document. And we're going to call this document 2025. Call this one Soccer. I'll call this one SR Tutorial, just so it doesn't get confused with that Soccer Rebounder that's in the public space for you. So this is our 2025 SR Tutorial, our Soccer Rebounder. And what we've got here is we've got a PartStudio down here, PartStudio down here. And we're going to work in that PartStudio to create the wood parts. So what I'm going to do is right mouse button on that PartStudio and choose rename. And once we choose rename here, we can call this something like wood parts. Good, rename that. And we are going to be working with this part in inches. So we're going to go in here to our workspace units. So you fly out this hamburger menu here, workspace units, and we're going to say that we're working in inches. and we're going to set our mass to pound. We'll measure the mass of this thing, but just for fun, not for really any other reason, but we will set the mass to pounds here. So inches and pounds, and we hit the green check mark, and that changes those settings not only for the PartStudio, but for everything in the project. And that's going to be important because in our next lesson, we're going to actually create a variable studio using inches. So almost every time I start a new prototype, a new design, I start out with a hand sketch. You can see here what this hand sketch looks like. I'll bring this up on screen. But what we can see here is that this thing is going to be 48 wide by 18 high. It's going to use 3/4 inch plywood, and I want to make sure that there's a handle, and then there's some legs on the back of this thing. So the reason I bring that up right now is because one of the first things we're going to do in this project is we're going to create a variable studio. Now, that might seem a little bit weird, like we're already jumping into the variable studio. But the thing is, a lot of times when you're designing a project, you kind of know what the overall key dimensions are for the project. And in Onshape, if you get used to working with a variable studio, you can make changes very quickly. You can iterate on your design. And that's really important when you're trying to take an idea from just being in your head to being a prototype and ultimately taking it to market. So if we come down here in this lower left corner, we've got this plus. We're going to hit that plus, and then we're going to choose to create a new variable studio. And this is where we can go through and we can input the variables that we want to use in this project. So one of the first variables is going to be max width. We want this thing to be 48 inches. So you can type in max_width. There's no spaces here in these variables. It'll error if you try to make a space. Now, after you've created that name, you can press enter, and that takes you into the next box. So usually what I do is I just kind of name all my variables in batch on this step, and then I go through and I populate the values of each variable. So this is going to be max height, enter, and this one is going to be wood_thickness, enter, and then this one is going to be leg_offset. That's going to be the distance from the edge of the part to the leg. So leg offset, how far in is the leg offset? I'm going to have one called central gap. We'll see what that is in just a few moments. And then I'm going to have one called leg length. So maybe just take a moment, pause the tutorial, and make sure that you've got all those fields populated the same way I've got mine populated there. Max width, max height, wood thickness, leg offset, central gap, and leg length. And in your future prototypes, this is a good habit to get into. Even if you only know max width and max height, still a good habit to get into. All right, and now we're going to go through and populate the values. So as we mentioned in the hand sketch, the max width is going to be 48, and you can press enter. And then the max height here is going to be 18, enter. The wood thickness, 0.75, enter. The leg offset from the end of the part over to the leg, that's going to be 3 inches. And the central gap, so when the legs fold in and there's a gap in the middle, we're going to make that central gap 2 inches. And then the leg length, we're going to use an equation here. Now, this is where you can really leverage the power of variables. So for the leg length, we're going to create an equation here, and that equation is going to be hashtag, so you type shift and the number 3. And then you can use the up and down arrows here to go to an earlier variable. So the leg length here is going to be the max width, enter, and then you're going to type /2, and then you can press enter. So the max width over 2 is going to be the leg length. So it's taking 48 divided by 2, and that's giving us the leg length. Now, the truth is, this actually isn't going to be correct, because if we just took 48 and we cut it in half and that was our leg length, we're not really accounting for the offset, the offset from the end, and we're also not accounting for at least somewhat of a gap in the middle of the part. So let's expand this column here, the value column, expand this over a little bit like so, and then let's double click in this bottom one, and let's make that max width over 2. Let's put that inside of some parentheses. So now it's parenthesis max width over 2, and then this is going to be minus, and then it's going to be hashtag, and we'll go down here to leg offset, enter, and then minus, and we'll do hashtag again here, and we'll go down to central gap, and then that's also going to be over 2, since that's like a total gap over 2. And so then you could press enter and see what that equates to. And maybe if you want to just double check it, you could throw some more parentheses in there around that central gap over 2, so that it's minus central gap over 2 as a function. I think it's going to be the same value. Yeah, it's still 20 because it's it's solving division first, but it's still kind of cool. It makes it easier for you to look at this. And then over here in description for this one, I might just type in a note here like equation or equation driven, something like that, just so that when I'm looking at my variable studio, I realize, you know, all these numbers here are static, but this one is special. It's got this note on here, equation driven, just kind of helps me keep things in line. So that is your variable studio. And in the next lesson, we're going to start modeling up the parts in the PartStudio. We're going to be referencing these dimensions. So we're going to be using that hashtag and then the up and down arrows to get to these variables. And that way we'll have one central location where we can kind of change the overall dimensions. Very helpful when you are working with prototypes. If you like Variable Studio, be sure to hit the like button on this video, and let's get into the next lesson. All right, so now we're going to start creating the geometry for our parts. So we're going to go here from the Variable Studio tab down here to the tab for wood parts. This PartStudio tab down here for wood parts, and that's where we're going to be working, and we're going to be constructing multiple parts. So we'll create the main wall, we'll create the leg here, and then we'll take these and we'll put them into an assembly. So we're on this first tab here. I'm just going to slide this back over so we can see the entire screen. And let's start out here on our front plane. So find your front plane of this PartStudio. Front plane, S key, begin a sketch. So this is my S key menu. I use this a lot in Onshape, and if you right mouse button, you can choose customize, and that way you can add and remove commands from the S key menu. So if I didn't want some of the sheet metal commands that are on here, you know, last tutorial I did a lot of sheet metal, so I added some sheet metal commands. If I didn't want them on here, then I could take these off of this S key menu and maybe turn them back on when I do some more sheet metal. And if there's any commands that I reference here, just make sure that you know you can right click and you can choose customize. That way you can add those commands to your S key menu. So I'm going to choose the front plane, S key, begin a new sketch with the pencil. Then I'm going to press the letter N. That's the shortcut for normal 2. And now I'm going to sketch the geometry for this rebounder, and that geometry is going to be sketched as a rectangle. Now, again, I use the S key, and I bring up my rectangle command, and I'm just going to drop in a rectangle here. You know, it doesn't really matter what the dimensions are, 10, enter, 3, enter. Doesn't matter what the dimensions are, because in this next step, we're going to press escape. We're going to center this rectangle on the origin. So single click on the origin, single click on this lower line, Shift M. That's the shortcut for midpoint, Shift M, add the midpoint relationship. And then we're going to double click on this 10 dimension, and we're going to type hashtag, and then down, 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 max width. This links our dimension back to the Variable Studio. Enter, enter. Boom, that dimension becomes 48. And we're going to double click on this 3 dimension, hashtag, down, 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 max height, enter, enter. There we go. That creates the dimensions for that main wall. So now we're going to take that geometry and we're going to choose extrude. Now extrude is up here on your toolbar, but I've also got extrude on my S key menu when working in sketch mode. That way I can just press S, extrude, and we are going to extrude this out in the default direction. And for the depth is going to be 3/4 of an inch, but really the depth is going to be hashtag down, 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 wood thickness, enter, enter, enter. And there we go. That creates the geometry for our main wall. Now, this list down here at the bottom, this is what's called your parts list. And this is where if you rename this part, that'll be the name we use in our assembly and in our bill of materials and in our drawing. And we'll see how we link that a little bit later in the video. But for now, I'm going to click down there and I'm going to press Shift N and I'm going to call that main wall and enter. And then up here in my tree, I'll rename some of these as well. So I'll take this sketch here, Shift N. I'll call that like sketch for main wall plate. And then here I'll rename this feature something like main wall dash plate. Something to indicate that it's part of the main wall part, but that it's also kind of that main plate shape. And then the final things I'll do with this part is I will right click on this part and I'll say assign material. You know, ideally we make this out of like a nice hard maple. Let's see if we got that here in the library. So from the Onshape material library, I'm going to search for maple, and oh yeah, maple hard. I like it. And we hit the green check mark. So now we've got the appropriate material density, and then we can also right click on that part and go to edit appearance. And then we can just change the color of this part, make it look a little bit more like a block of wood. Okay, and that's it. We now have one part in our PartStudio, and in the next video, we're going to create our second part, which is going to be the leg. All right, so now that we've created that one part in our PartStudio, again, we're working down here in the PartStudio called Wood Parts. This is our parts list, and this first part is called Main Wall. Let's create a second part. Let's get in here and create the leg. So we're going to go over here to this surface. Now, we could begin sketching on this surface, and then Onshape has an option when you go to extrude. You could say extrude and start at an offset. So we could sketch the leg here, and then when we go to extrude, we could have it show up over here with what's called an offset. That certainly works, but just for me personally, I prefer to make an explicit plane. I just think it helps me kind of organize the tree and organize my thoughts, and especially when I'm in this early prototyping phase, I really want to try to keep things organized. So I'm going to create a new explicit plane, and to accomplish that, I'm going to click on this face, and then I'm going to choose the icon here for plane. Now, I use this icon quite a bit. I make quite a few planes in my designs, so this is another one that I've got mapped to the S key. So I pick that face, S key, plane, and then this plane is going to get offset to a distance of 3, but really it's going to get offset to a distance of hashtag down, down, leg offset. This is where our legs are going to be sketched, and they're not going to be all the way out on the end. They're going to be offset in a few inches. So the leg offset is going to be 3, and then I'm going to click on this arrow here to flip the direction of the plane, because currently it's going to the outside. I want that to be going to the inside. So we hit the green check mark. We could rename that feature, Shift N, call it something like plane for leg sketch, something like that. And now we've got a new plane over here. Let's click on that plane and S key, begin a sketch, and then press the letter N, and that gets you normal too. So now we're ready to start sketching for this leg, and the sketch for this leg is just going to be some lines. So you can begin the line command, single click here, bring a line over like so. We're just going to kind of eyeball it up, bring a line up like so, bring a line up at an angle like so, and then back over here directly above the origin, and then we'll close that off. Okay, so this is where it's helpful that we have the origin located right here. If you didn't have the origin there, you could maybe add a collinear relationship between this line and this edge of the main plate, and that would work fine as well. So now that we've got that shape kind of in place, let's add some dimensions. So we'll go here to dimension, so S key dimension, or you could come up here to your toolbar. Dimension is up here in your toolbar somewhere. Can't even find it. Here it is, dimension. But I just use S key dimension. So we don't really know what these lengths are going to be, so we can just kind of drop in random numbers for now. And we do know what this angle is supposed to be. So this is supposed to be 30 for the angle. So that's good there. And then we also know that we want to take this whole thing and we want to flip it over. We want to take the whole thing and we want to be able to flip it over and have it set on the ground. And when it's setting on the ground, we want this leg here and we want this line here, or this point really, this I'll put it in blue here, this point here, we want that all to be setting on the ground. We want that to be coplanar or collinear. So what we could do to kind of help ourselves visualize that is we could create what's called a construction line. So we could create a construction line that starts here, okay, and then you press the letter Q, and that turns that into a construction line. And then you can press escape here, and then you can click on that line, and you can click on this line here, and you can say you want those two to be collinear, and we can do that using the letter I. If you press the letter I, that makes those two collinear. But now you can see we're running into a little bit of a problem. See, this point here and this line, they're not going to line up now. And the reason why is because that location is based on this distance here, and the angle. So if, for example, if we were to come in here and take this point, so if you grab this point here and kind of just move it down here, if we were to take this point, whoops, I didn't mean to make that vertical. If we were to take this point here and click on this point and then make this point and this point here coincident, you know, what's going to happen? We're going to end up over defining the sketch. So if we press the letter I for coincident, look at that, the sketch goes over defined, and that's not what we want. Well, when something like this happens in Onshape, what you can remember is you could delete this dimension, but you can also right-click on the dimension, and you've got this option, Change Dimension to Driven. And that's pretty nice because now we can leave this dimension behind just as like a reference, but it also allows us to complete the sketch, and we can end up here with this nice, fully defined sketch, and we're able to kind of program in some of our prototyping. You know, maybe eventually this dimension ends up being like 7.51, 10. And that way we could just make it 7.5 for the prototype, make it easy for the people on the shop floor to do the cuts. So it's nice to be able to kind of see that reference. And of course, that dimension is going to change. If this changed to 15, that dimension is going to change. If this changes to 22, that dimension is going to change. So that's what we call a driven dimension in Onshape. So for this dimension up here, this blue line that's still under constrained, let's add a dimension from the top of the model, and we'll just make that 6 inches. And what we're thinking there is that we want to have clearance for the handle, and we also want to have a brace running across the back of this assembly. So that 6 inches should give us some pretty good clearance there. But of course, we could maybe change that at some point in the future. We're going to test this thing. We're going to experiment with some different sizing. All right, and then the final dimension for this part of the leg is going to be this dimension here, this 22. We're going to double click on that, and we're going to type in hashtag, and this is going to be our leg length. So leg length, enter, and there we go. There is our leg. And so this is looking pretty good, I think. Let's take this and turn it into an extrusion. So we choose extrude, and then for the extrusion here, this is going to be a new part. So you can see here that it's currently set to add. And if we look down here in the parts list, we've only got one part in the parts list, main wall. Well, as soon as we click new here, we'll see that now there's a new part being added to the parts list, part 2. So we're creating multiple parts in one single PartStudio. And then for the depth of that extrusion, it's going to be hashtag, and we'll go down, wood thickness, and we'll press enter. And then we want to make sure this is going the correct direction. We want this going inward. So we'll flip the direction on this thing. There we go. Now it's going inward. So we hit the green check mark. Look at that. We created a new part here in the tree. So we'll rename this feature here. Instead of extrude 1, we could call that something like leg dash main shape, the main shape of the leg. And then down here in the parts list, we could rename that as well. We could call that leg. And that way, that's the name that shows up in our assembly and our bill of materials and maybe in some other spots. So now let's just add a couple of more features just for style here to the leg. So we'll pick on the leg here, S key, begin a sketch, N key to get normal to, and then we will S key. We're going to create an arc here. So I'm using this 3-point arc command. You can also get that up here from your toolbars. So we're going to create this 3-point arc, and we'll drop in an arc here that looks a little something like this. And then let's just hit escape, and then we'll jump into some dimensions. So the dimension here is going to be from this wall over to this point. We'll make that 2 inches. We'll make a dimension here from the origin over to this point. We'll make that dimension 2 inches as well. Whoops, try it again. From the origin over to this point, we'll make that 2 inches as well. And then we'll create a dimension here from this bottom line to the arc. We'll make that dimension 1 inch. So now let's just draw a single line running across the bottom here, single line here running across the bottom, and then we can do extrude, and that extrusion is going to be remove, because it's a cut, and through all. So extrude, remove, through all, green check mark. There we go. We got a little curve there running along the bottom of the leg. Just a little bit of style there. And then finally, we'll pick on this face here, S key, begin a sketch, N key to get normal to. And what we're going to do here is we're going to use what's called an offset command. So we're sketching on this face here. We're going to click on this command here, offset. And then we're just going to pick on this face. And what Onshape does is it creates an offset running around that entire face. Now, you'll notice your mouse is saying if you left click in the background, that's kind of like hitting a green check mark. So we're going to do that, left click in the background, and then we're going to type in an offset distance here of 3. So 3, enter, and that gives us that offset there of 3 inches. So we're just offsetting this whole thing 3 inches. You can see here that we're running into a little bit of an issue here. We've got these kind of overlaps here in the sketch, but this is really no problem for Onshape. What we can do is we can just click inside this region here and then choose extrude. So Onshape will just ignore these extra triangles, and when we go here to extrude, we can say we want that to be a remove through all, and there we go. We've cut that nice window there in the leg. So over here in the tree, I might rename some of these features. Maybe this bottom one, I'd call this one Shift-N, leg, bottom curve, cut, bottom curve cut. And then this one here, so I'm clicking on this one again to deselect it. You can see currently I've got that number 1 next to my mouse. So click on that again, come down here on this extrude 2, Shift-N, and this one will be called leg window cut. There we go. And then the final feature I'm going to add to this window is just going to be a fillet. So I'm going to add in a fillet here. I'll make this fillet, let's say, a radius of 0.5. And then this is a little trick in Onshape. You know, this edge here, very easy to select. No problem. This edge here, maybe a little bit more difficult. Well, what I can do is a window up in this area, and I can then select right through and get that edge. And that has been an enormous time saver for me. So I can do a window here to get this one. I can do a window here to get this one. I can do a window here to get this one. And of course, there's other tools you can use like select other, but I just think that window is so sweet. It just works really well and saves me kind of having to rotate the view. So there we go. We fill it off those 5 edges, and then we would probably rename this feature to something like leg dash window cut fillets. And now we've got our 2 parts. I think we're ready to put this into an assembly. Let's just change the color of this part. Right mouse button on the part down here in the parts list, edit appearance. Change this to, again, like kind of a woodsy looking color, or we can make this gray. Make it like it's painted like a light gray or a beige. All right, I like that. We hit the check mark and then right click and assign material. Let's give this a material of maple. I like that, maple hard. Let's go. All right, we hit the green check mark, and that's it for our first 2 parts in the PartStudio. In the next video, we're going to take these parts, we're going to add them to an assembly. We're going to make a second instance of the leg so that we get multiple quantities in our bill of materials, and we'll do a little bit of testing on how the legs open and close and if they actually open and close properly. So if you like what you're seeing so far, be sure to hit the like button. Be sure to leave us some comments down below. Let us know what you think about this Onshape step-by-step tutorial, and I'll see you in the next lesson. All right, so now what we've got is 2 parts here in the PartStudio, and we are going to take these parts and add them to an assembly. Now, every time you start a new Onshape document, you're going to have this tab here for assembly and this tab here for your PartStudio. So we can just jump over to this tab here for assembly, and then we're going to use insert to insert parts into this assembly. You can also press the S key, and you can use insert there, and we can pick multiple parts. I'm going to do this in 2 steps, but it doesn't really matter. You could pick them all at the same time. So I'm going to pick main wall. I'm going to hit the green check mark, and then I'm going to right click on main wall over here and choose fix. And what that does is it sets you up so that the main wall is not able to be dragged around. It's fixed, meaning it's totally locked in place. And now I'm going to do insert, and I'm going to choose the leg, and I'm going to choose the green check mark. Now, you know, a moment ago, I brought in the wall and I fixed it. The leg is not fixed, so the leg can move anywhere. So if we press Control Z, that's our undo command, that puts it back to where it originally was. Well, what we can do here with this leg is we can choose the command group. So group is this command up here, group. And what group lets you do is say that there's going to be 0 relative movement between the 2 components. So in other words, it's almost like you're super gluing the one component to the other component. So I'm going to say group this component and this component together, and we hit the green check mark. And now if I go to move the leg, now the leg cannot move. So now that we've created that assembly, let's rename this tab down here. So we'll right click, we'll say rename, we'll call that something like Soccer Rebounder. Okay, that'll make it easier for us to find that component and to use that component when we put it into our drawing. I'm going to move this tab back over just so that we can see a little bit more of the screen. And now we're going to launch the mirror component command to make a mirror of this part. So we'll go up here to search tools and we can search for mirror. And you can see here it says assembly mirror. So we're going to mirror. And the component that we're going to mirror is going to be this component here. And then for the mirror plane, we can wake up a mate connector here. So if you just kind of put your mouse over this lower edge of the main wall, you'll see the mate connector will show up, and you see it's oriented kind of like with the Z axis pointing this way. So that's the one that you want. So then you can just kind of click on that leg, and that'll pick up that mate connector there. And there you can see that we are now taking this component and we're mirroring it over to here. Now, when you're in assembly mirror, you've got this button here for mirror strategy. And if you click on that button, you'll see that you've got options like creating a left-hand, right-hand version, which is what derived is, or just doing a transform where we just take the original and we basically move it over the exact same copy. And there's not a left-hand, right-hand version of this leg. We're not pre-drilling any holes or anything. So the transform option works perfect for this. So I'll click on the little X here to close out of the mirror strategy. And now we have made a mirror of that leg, and we can hit the green check mark, and Yes, this thing is looking good. Now, one thing that I like to do when I'm looking through a model like this and when I've created a variable studio is I like to go over here to this tab for the variable studio, and I like to start making changes to this thing. So I'm going to change here the max width from 48 inches. I'm going to change that to a little bit larger here. Maybe we'll make this like 60 inches. So make this thing a little bit larger. And you'll see when I did that, the leg automatically increased in length. So if I change this back to 48, you can see that the leg goes back to its original length. Okay, so if we change this back to 60, we see the leg gets a little bit longer. And then we could also change this height here to maybe 24 inches, so 60 by 24. Oh, I like that. You know, the one that I have, I feel like sometimes it sits a little bit too low. Sometimes I end up kicking the ball over top of it. So I wouldn't mind having one that's maybe a little bit larger of a surface area to kick into. So this is something that you can do and that you should do really when you are testing your prototypes, is maybe test them out in some different sizes, see if anything changes it's going to be problematic. And I'm happy to see here that everything looks to be updating correctly. So I'm going to go back through those options and I'm going to change my values here back to 48 and 18. And then I'm going to click on this tab here and close the variable studio. Now, I'd like to also confirm that those legs are going to open and close properly, and I'm not going to run into any issues. And one way that I could do that is I could import the assembly of the 90-degree locking hinge. But remember, this is meant to be kind of like a quick prototype. We just want to get this out to the floor so we can build the prototype. So we don't need to have it be an exact one-to-one of what the final product will look like. And what we could do is we could click on this leg here and press Control-C, and then click in the background and press Control-V. And you can see that makes a copy of that leg. And then what we could do with this copy is we could click on the mate type here. Whoops, the mate type here, cylinder mate, and we could create a cylinder mate using this mate connector. So I'll just use this mate connector here at kind of the bottom of this edge. You could do it at the middle or the bottom of the edge there, but just pick on that edge and get that edge. And we're going to go to the same mate connector down here. So we click on this edge, we get the mate connector down at the bottom, and we align those two so that they've got no axial only axial rotation. And then what we could also do is we can say that we want there to be a limit on this mate. Now let me show you the kind of before and after here. So I'm going to hit the green check mark, and then I'm going to click on this third leg here, and you'll see that we can take this third leg and we can use this rotation direction here to kind of rotate the leg. But you'll also notice that if we click and drag on this leg, we not only have the ability to rotate the leg, you can see I can grab it here and rotate the leg, but I can also drag this leg up and down and I can move it. It's got axial translation. So what we can do to lock that down is go back to that cylinder mate. We could double click on that cylinder mate and then apply a limit here. And the limit that we're going to apply here is going to be a limit for the distance, and that limit is going to be 0 and 0. So the max translation in Z is 0. The minimum translation in Z is 0. So I can hit the green check mark there. And now you'll see that if I click on this leg and I go to rotate it again, now I can rotate it. I can drag this here. I click on it the first time because it brings up that triad. And then you can see I can drag it here. I can rotate it, but I can't move it up and down. And so then the other limit that we could put on this leg would be that we could double click on that cylindrical mate, and we could say there's going to be an angle limit as well. Maybe if we go here from like 270 to 360. Let's see how that looks. So we hit the check mark, and then let's click on this leg again and try to move this. There we go. 270 to 360. That did the trick. Okay, and now we can just click on this leg, and you can see we can move this leg open and close, and that is pretty nice. You can see, again, if we were to actually create the 90-degree locking hinge, it would be a pretty similar motion. You know, the locking hinge would sit in here like this. You'd have the locking hinge here that would sit in here like this, and then it would just kind of fold forward. So it would end up sticking out a little bit further because you'd have the width of the locking hinge. But as far as the translation of kind of the point that we're interested in, the point when this thing comes together in the center, I think it's going to get us pretty close. Maybe we'll leave ourselves like an inch or two of clearance, but I think that should get us pretty close. So what I'd really like to see is I'd like to see both of the legs kind of opening and closing. So let's take this leg here in the tree and we'll roll it up in the tree here before the mirror. So we'll just take this leg here and just kind of move it in the tree. I just grabbed it and dragged it. And then we can double click on the mirror to edit that feature. And here in the instances to mirror, we can also add in this leg here. And so now when we hit the green check mark, now we can see that we can open and close this thing. And we can kind of see how close they're getting together in the middle there. And, you know, maybe that's a little too close for comfort. comfort. It's also going to be difficult to reach in there, with your hand and grab the leg to pull it apart. So if we go back to our variable studio, you can see here that we can then change what that central gap is. So maybe instead of 2, we could change that to like 5 inches. See what that does. So that decreases the length of our leg because the leg length is based on the equation, which is based on that central gap. Maybe that's a little too much. Maybe I went a little too crazy there. How about maybe 3 inches? Oh, yeah, that looks good. I like that. So 48, 18, 0.75, 3 inch for the leg offset, and then 3 inch here for the central gap. If we wanted to decrease that leg offset, we could type in a new number there, and you see that moves the leg over, and then it also increases the leg so that that central gap remains whatever we created there. So I'll change that back to 3, and this thing's looking pretty good. Okay, and you can always suppress and unsuppress. Whoops, I'm going to click on the variable. And I'm going to click on the variable table here. And you could always suppress and unsuppress these extra instances. So, you've got this thing for motion just for testing, but you don't want to mess up your bill of materials. So maybe you could come back here and you could take that extra leg and then you could right click on it and choose suppress. It's kind of like turning it off. You can choose suppress, turn that off so that suppresses that extra leg so it doesn't show up in the bill of materials. But then if we ever wanted to see that motion again, we could choose unsuppress. And I just think it's kind of like a nice quick way that you can get in there and do some prototyping, do some testing, and kind of take a look at what your variable studio is doing to the assembly. So now we're going to go back into the PartStudio. We're going to add one more part, that brace on the back. Maybe we'll make a couple of additional features on the main plate, and then I think we're going to be ready to add this thing to a drawing. All right, so we're going to add one more component to this assembly, and we're going to do this back in the PartStudio. So if we go back here to this first tab, the wood parts, that's our PartStudio, where we've got multiple parts here in this PartStudio. What we're going to do here is we're going to add in the brace that runs across the back here. We're kind of spanning a long distance here with a piece of wood, and we don't want the wood to bow, so we'll just add in an additional brace there. That should also give us a little bit more of a reflector. It'll actually bounce off the wood a little bit stronger if it's not curving and not giving a little bit. So we're going to add in that component, but we want to make sure that we have enough room for that component, and that means that we need to kind of map out where the handle is going to be. So let's start out here by adding a feature to the main plate. So we're here on the first tab, the PartStudio tab. We are going to click on this face, S key, begin a sketch, and we're going to end up sketching a rectangle for the handle. So this face here, begin a sketch, S key. You're in sketch mode now. Press the letter N, that gets you normal 2. Press the letter S, you can create a rectangle. This time I'm going to use the center point rectangle option. Got that from my S key menu, but the center point rectangle option, and that way I can create a rectangle that is exactly above the origin. So if you just put your mouse over the origin to begin with and then move your mouse straight up, you'll see you're getting that vertical relationship. Single click, move your mouse over, single click again, let go of your mouse, and you can type in 5, enter, 1.5, enter. That gives you the rectangle for that handle. Now you can press the S key and go to your dimension command, and you can make a dimension here that goes from the top of the plate, the main plate, down to that handle. And that dimension is going to be 1.5 inches. So that is the geometry for your handle. Now we can S key extrude. And when we S key extrude here, this is going to be a remove and through all. And there we go. That is looking good. And then we can use our little trick again to add in those fillets. So we're going to do a fillet here. We're going to say we want that fillet to be 0.375, and we will put a window here around this edge, a window here around this edge, a window here around this edge, a window here around this edge. I like that shortcut. I've been using that one a lot lately. Really cool shortcut there for quickly adding those fillets. And then we can also add fillets here to these outside edges of the plate. So S key fillet. Maybe we'll make these a little bit bigger, like 1 inch, or 1 inch is probably good. So this corner here, this corner here, this corner here, this corner here. All right. So that takes care of the main plate, and now we have a little bit of a better understanding of where this brace can go along this back surface. And I think that to create the sketch of this brace, I'm just going to create it on the right plane of the model. So if we go over here to the right plane of the model, we can see this is the plane that's kind of cutting right down through. So we'll right-click on that right plane, begin a new sketch, or you could click on it and press the S key, begin a new sketch. Either one works. Pick there on the right plane, S key, begin a new sketch. And then we're just going to sketch a rectangle here. We could do the corner rectangle for this one. So create a rectangle here like so, and that rectangle is going to have a 1.5 by 1.5 dimension. So 1.5 by 1.5 brace here. And then what we'll do is we'll create some relationships. So we can hit escape here. You could press the letter N if you want to get normal 2. You could say that there's a relationship between the origin. The origin is down here. Sometimes when I go to pick the origin, I'll kind of put my mouse right here, almost like down and to the right of the origin. So you can click on the origin. You can click on this point here. You can press V on your keyboard for vertical. Gives that a vertical relationship, makes that vertical. And then we could add in a dimension here. Maybe we could add in this dimension from the handle. So we could do S key dimension, and then we could add in a dimension here from the handle, maybe from the midpoint of this edge to this edge here of our rectangle. And we could make that, let's say 1 inch below. 1 inch below should be pretty good there for the location of that brace. Give us a little bit of a gap there, so if we reach down to grab the handle, we don't accidentally grab that brace. And so now we're going to take that geometry and we're going to choose to extrude it. So S key extrude, and this is going to be a new part. New part. So when we click new, we should see a new part show up down here in the parts list. So new, there it is, part 3. And then this new part is going to go to a depth of hashtag, and we'll go down, 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 max width, enter. And then we'll go down here and we'll hit the check mark for symmetric. So there we go, creating a new part, that brace, and that's gonna be symmetric. We hit the green check mark, and then we can just add a couple of fillets to the back of this. So S key, fillet, maybe we'll make these like 0.5, and we'll add a fillet here to 0.5. And we'll add that fillet here to this edge and this edge, 0.5 for the radius. Just add a little fillet there coming off of that brace. And so we hit the green check mark, and there we go. There is our rear brace. Just like we did on the other components, we're going to want to rename up here in the tree, and we're also going to want to rename down here. We can do Shift N for the name. We can call that something like rear brace. We can right click on that part. We can go to Assign Material, and here from the Onshape material library, we can search for maple. Yes, maple, hard, good. And then we can also right click on that brace and we can go to edit appearance, and we can just give this thing a new color, kind of make it look a little bit more like it's made from wood. So there we go. There is the rear brace. And now we've got these 1, 2, 3 parts here in this PartStudio. Let's take that rear brace and add it to our assembly. So we come over here to the assembly for the rebounder, and we can do S key, insert. We can go in here to our PartStudio list here. We can choose the rear brace, and then we can choose the green check mark, and that just adds it right into the assembly exactly where it's located in the PartStudio. However, if we grab that part and we try to move it, it's free to move anywhere we want. So we're going to press Control Z, and then what we're going to do is we're going to go over here to our group. So the group is already there. We can just edit the existing group. So we double click on the group, and then we can click on the rear brace, and we can add that into the group. And so now if we go to move that rear brace, it does not move. And so there we go. There is our assembly. You know, again, we could get in here and we could do some testing. We could go to our variable studio. We could say we want the max height here to change to 24 again. See what that does to the brace. So the brace moves up right along with it. It looks like we got some nice clearance underneath the brace here. If we wanted to, we could change the location of the brace relative to the handle to give us a little bit more room for these legs, or we could change the dimension to the leg and kind of push the legs down a little bit. But I think this thing is looking pretty good. I like the way it's updating as we change the values in the variable studio. It's a real handy workflow there, and it really helps you to kind of validate your designs quickly as you are going through and putting together this prototype. So I think we're just about ready to add this to the drawing. I think the one thing that I'll do here is I'll just go to the that second leg, and I'll suppress that, and that way we should be ready to add this thing to the drawing, which we're going to do in the next lesson. All right, so now that we've got all those components together in the assembly, one last thing that we didn't do in the previous video, we could click this button down here, display the mass properties. So we can click this button and we can look at the mass of the assembly of all the components, and we could say, what does this thing weigh? 24.955 pounds, 25 pounds, pretty good, pretty hefty, but that's what we want. We want this thing to have some girth to it, some mass to it. So 25 pounds, not bad. All right, now let's take this assembly and add it to the drawing. So so that we can create some actual physical drawings. We can create some cut lists and we can share that with the shop floor. So we're going to go down here to the plus sign to add a new tab to our Onshape document. And that new tab is going to be a drawing. So we say create drawing. And then here you can see that we can create a drawing using existing templates. And we've got all, ANSI, ISO, or JIS. So we're going to go back here to all, and you can see there's this button here that says Show Onshape Drawing Templates. So this gives you the full list: ANSI inch A size, ANSI millimeter A size, ANSI A portrait inch, A portrait millimeter, etc., etc. So you can see here that you've got quite a few different templates you can choose from, but we're going to be just printing this out on a regular 2D printer. So we're going to go with the A ANSI inch template. So we double click there, or you choose there and choose OK. And this opens up the Onshape drawings environment. And so from here, what we can do is we can choose the assembly. So right away, you're prompted to insert a drawing view. That's what this option does here. We're going to do this again in just a little bit. We're going to insert another drawing view. But right away, you're going to be asked to insert a drawing view. And so we're going to insert from the assembly. We're going to choose the ASSM Rebounder. You notice that's the name of the tab down here. So the ASSM Rebounder. So we're going to choose that. And then we're going to take our mouse out on the screen. You can see that the view that we're adding, so we're doing an insert drawing view here. The view that we're adding here is a front drawing view. Okay, so we're going to add in that front drawing view. And then what happens is once you're done with that front drawing view, if you move your mouse straight up, you can drop in a top drawing view. There we go. And then if you move your mouse back down and just click on this front drawing view again, then you can move your mouse over and you can drop in a side drawing view. And then if you move your mouse back over here on this first view again and click one more time and move your mouse kind of up and at an angle, you can drop in an isometric view. So now that we're done adding in those views, we can hit escape. We're done with the views, and we can see that up here in our drawings toolbar, we're on the drawings tab. So I'm just going to move this back over here. We can see that up here on the drawings toolbar, we've got some different view types. We can insert a view from the model. We can insert a projected view. We've got some other view types here. One of them here that I want to try to use right now is called a section view. So we can choose this option here for section view, and then you can take your mouse out here on the screen and you can drop it right here, right at the middle of the top edge of the rebounder in the front view. And then you'll see that you can move your mouse over here and you can drop in a section view looking in from the side. So maybe that makes it a little bit easier to call out what's going on in the middle of this part, or maybe call out what's going on with this solid bar, with this bar that's going across the top here. So it's kind of cool that you can really easily get in there and create section views when you're creating these drawings. Another thing that will come up when you're creating drawings is how are the hidden lines handled? You know, behind this main plate, we've got the leg here that's sticking up. How can I show that leg so I can add a dimension to it? Well, what we can do is we can right click on that view, and then you've got under the right click, you've got this show hide option. So show hide, show hidden lines. And there we go. There are the hidden lines for that view. And we can do the same thing in the top view here. Right click and we can say show hide and we can say show hidden lines. And that shows us the hidden lines there in that top view as well. Now, another thing that we can do there with that show hide is we could right click on this view here and we could say show hide and we could say show shaded view. So sometimes when when you're printing out your drawings or when you're sharing your drawings in PDF, it can be helpful to actually see the shaded view. It can kind of help to kind of break up the monotony a little bit and show actually what these parts look like as a shaded model versus just a line drawing. Now, another thing that we can do here is we can rename this tab as well. This is helpful when you're creating different drawing bundles. So down here at the bottom, you've got the name of the tab here. We could rename this. We could call it something like call this something like draw-rebounder tab. Now, normally you wouldn't call it tab. I'm just going to rename it that now just so that we can kind of see the difference between some of the different elements here. So that's the rebounder tab. If we go over here and we click on this button, then we'll see all the different sheets that are part of this drawing. So if I click on this button here, this shows us all the different sheets that are part of this drawing. And currently, we only have one sheet in this drawing. You've got this one here, sheet 1. Well, in just a few steps, we're going to add another sheet, and then we'll see how it can be beneficial beneficial to actually rename some of these different sheets. So the sheet is currently called sheet 1. We'll take a look in just a moment about how to rename that sheet. Okay, and the final thing that we're going to do here in this video is we are going to come down here into the title block, and in the title block, we're just going to kind of clean up the title block a little bit. This is really just lines and notes. So what we could do is we could do a crossing select here. This is a crossing select because we start at the right and we move to the left. And when we do that crossing select, we can kind of select everything there and press delete. And that cleans up that title block a little bit, get some of the unnecessary information out of there. Or we could also use commands like trim. So if we were to click on this line here and press delete, then we could use the trim command and we could click here on this line and we could trim this line away. So you can do this using a delete command. You could also use it doing a trim command. You've got the trim command here to kind of clean up your title block. Now, these notes that are listed here can be linked to different properties that are found throughout the project, but you can also just double click on those notes. So I could double click on this first note up top here, and when I double click, it takes me into an edit, and I could call this something like Onshape. And then the second note here, I could call this something like Rebounder, or I could call this one actually Soccer. And then for this third note here, I could double click on this one and I could call this something like Rebounder. So you can link these two properties that are found throughout the project, and we'll talk more about properties in a future video. But you can also just kind of almost like down and dirty, just get in there and rename those fields. So here, maybe we could call this something like RB-6001, the Rebounder 6001. And we could also rename the sheet to kind of match that. We could come up here to the name of the sheet. So here you see you've got this button here that brings out the drawing tree and shows you the names of things. We could rename the sheet there. You could go here to where it says sheet 1. We could say rename. We could call this something like RB-6001. Okay, and so we've got some different options here in Onshape as far as dynamically linking these types of things, but for now, we're just going to manually rename it. And that's where we're going to stop this video. In the next video, what we're going to do is we're going to get in and we're going to start working with the bill of materials for these drawing views. Oh, you know what? Actually, let me just show you one more thing here before we get out of this view. When we go to create the bill of materials, it might be beneficial to see this thing from the back side, because then we could add a balloon to that rear brace. Well, the way that we do that is we open up the assembly. So you can right click here and you can say switch to assembly. And then once this assembly is open, we could rotate this around to get it into a good view that we'd like to see in our drawing. And then over here in this menu right here, we can fly out this menu and go to what are called named views. So if we choose named views there, we could call this one something like reverse ISO. Got ISO from the backside, reverse ISO. And we say add view. Okay, and then you can close out of this window here. And now we can return to the drawing. So we can click here on the drawing. And then up here in the drawing menu, this is kind of how we started with the drawing. We use this insert view command. Well, if we use that command again, we can choose the assembly, the rebounder assembly. If we wanted to use something else, like a different part or something, we click on this button here. Then we can choose the parts from the PartStudio or the assembly. We're going to choose the assembly. And then here in this menu, view orientation, we now have reverse ISO. So we can choose that reverse ISO and then drop in that view there. And that will make it a little bit easier for us to call out that rear brace when we go to add our balloons to our assembly drawing. So like I said, we're going to do that in the next lesson. Let me just right mouse button on this view. I'm going to go to show hide. I'm going to say show shaded view. Oh yeah, this drawing is looking good. This thing is coming together fast. So if you guys like what you're seeing so far, be sure to hit the like button. Leave me some comments down below. Let me know what you learned so far in this tutorial. And in the next lesson, we'll start adding in the bill of materials and the balloons. So to move these views around, what you can do is just grab the view and begin dragging, and then you'll see the views that are projected off of that view will line up. They'll kind of fall into line there. You can also examine the properties of the individual sheets by coming over here into the tree. So you click over here in this tree for the drawing, and then you can right click on the sheet. So I'm going to right click here on this RB 6001, and I'm going to choose properties. And one of the properties that's there for the entire sheet is the scale. So if we brought this down a little bit, like maybe make it 1:18, you can see that the views all get a little bit larger, and that's just going to make it easier for us to call out information on these views. So you can move the views by dragging them around. You know, each view is going to have its own properties also. So if I double click here on this view, the reverse ISO view, then I've also got a scale factor for just that view. But a lot of times we want to change the scale for the entire sheet, and we do that up here on the properties of the sheet. All right, so now we are ready to add in our bill of materials, and we're going to do that up top here using this icon from the drawings. This is your insert bill of materials table, and you'll notice here that when I go to add my bill of materials table, the option that I have to add my bill of materials table is the name of the assembly that we're referencing, the template that we're going to be using, so follow assembly or Onshape default, and then we've got this option here, BOM type, flattened, and then order, top to bottom, and then you've got this select fixed corner. So for our example here, we're going to use this option. Select fixed corner is going to be this first option, the kind of upper left, and then we're going to take our mouse over here and we're going to click here in this upper corner of the drawing. And there we go. That drops in our bill of materials. Now, one of the things that new users find a little confusing about the Onshape bill of materials is, how do I change these columns? How do I change this column here so it's referencing something else? I don't want it to be referencing the part number. I want it to be referencing the name of the part in the PartStudio, in the parts list in the PartStudio. So if I go back here to this tab, this is the PartStudio tab. I've got these names here that I've established. I want to use those names in my bill of materials. Well, what's interesting about Onshape is that we don't do that here in the drawing. We don't make those changes here in the drawing. Instead, we make these changes here in the assembly. So here in the assembly, what we can do at any point is we can bring up the bill of materials, and whatever we do here on this bill of materials, that's this tab over here, whatever we do here on this bill of materials is going to be reflected in our bill of materials in the drawing. So what that means is we could go over here and say add column. So click on this button here, add column. And the column that we go to add here could be name. So you can see you've got all these different fields here. Well, we could add a column for name. Well, what does that use? It uses the name of the part from the parts list, and that's exactly what we want. So I like that. I like that. All right. And so then what we could do is we could maybe get rid of this part number column. So right mouse button, we could say remove column. And then we've also got this description column here. Now, where is that description coming from? Well, the description is coming from the individual components, the individual parts. So if we go back over here to the PartStudio, so here's the PartStudio, and then we look at these individual components here, we could right click on this component and we can go to properties. And what we're looking at here is we're looking at the properties of this component. So we could call this something like maple wood 0.75 THK. And we could say apply and close. And then if we go back over here to the assembly, we can see that now that description field has automatically populated maple wood 0.75 thick. The cool thing is that I can take that field here, Control C, and then go in here to these other fields, Control V, Control V. And then if I go back to the PartStudio and I look at one of those other parts, like let's say I look at the leg and I go to properties of the leg, well, look at that. The description has automatically filled in. So when you edit it in one spot, it updates in the other spots. And ultimately, we're hoping that we can get this to feed back into our drawing. So let's maybe take the name here and move the name over. So right click, move left. There we go. So now we've got item, quantity, name, description. And now let's look at our drawing, and we're going to click this button here in our drawing. This is one that you use a lot in your drawing to kind of refresh and update your drawing and the different dynamic elements in your drawing. And once that updates, look at that. That is what we were hoping for. We like this. So now we see that our bill of materials that we set up, that we configure, that we lay out over in the assembly mode. So here in assembly mode, this bill of materials here automatically feeds directly into our drawing. And that gives us this really nice bill of materials here in the drawing. This is something that, you know, we could take this drawing, we could print this out and take it with us to the hardware store and pick up the lumber that we need, and or take it out to the shop. And it's going to be able to really provide us with a lot of valuable information for getting that prototype built. So now that we've got a bill of materials, we can go in here and we can add in some balloon information. So here are our balloons. We can choose this balloon command here, and then we could say this is an item number, from our bomb. This is an item number from our bomb. This is an item number here from our bomb. And this is an item number here on that rear brace from our bomb. So we can just quickly go through. We can add in those item numbers. That's going to make it really easy to follow along with that drawing. Now, this first drawing view here is what we would consider an assembly view. And a lot of times in the assembly view, what you do is you show the dimensions for how things are going to be put together. So for this drawing, what I would do is I would go up here to my dimension command. This is also available on your S key. I would go up here to my dimension command, and I would add in some overall dimensions of this thing. So the overall width of this thing, the overall depth of this thing, the overall height of this thing. These are the dimensions you would probably include in your assembly view of these components. You'd also want to include some information about how the components are oriented relative to one another. So for example, this offset distance here for the legs, for the location of the legs, you'd probably want to include that here in your assembly drawing view. So maybe I'll move this view over a bit, and then I can add that 3 on this side as well. So S key dimension, we could add that 3 here as well. And we'd want to indicate where that brace is located relative to the top of the model. So we could do that here in the section view from the top of the model down to that brace. It's, so far, it's this far, 4 inches. So that's the type of information that you would want to include. There, what I did was I pressed the letter F, which is zoom for fit. And that's the type of information that you would want to include in your overall assembly drawing view. Now, a lot of times we want to create additional drawing views as well. And so to accomplish that, what we would do is we would add a new sheet to the drawing, and we're going to do that in the next lesson. So we've created a drawing that helps our assembly team understand how to put these components together and what the distances are between components. But now we need to clearly specify where this handle should be located on this front plate. And so to accomplish that, we can create a new drawing sheet. So here you can see I expanded the drawing menu over here on the left, and then I'm going to click on this icon here to add a new sheet. So we click on that icon, and maybe this sheet could be called something like, let's rename this. We'll call this something like 001 main wall, something like that. And then we can go here to the command insert view. And this time, instead of inserting a view of the entire assembly, we're going to click on this button here that says insert. And then we're going to browse into our PartStudio, and we're going to click the main wall. So here in our PartStudio, we click the main wall, and this lets us bring in a drawing view of just that component. So you click here, drop in that first drawing view. We move our mouse up. What this is going to let us do is project a view upward. We can come back and touch on this front view again, move our mouse over, project a view over to the side, come back here, touch on this view again, and move our mouse up and at an angle, and that lets us create an isometric view of that part. So now that we've got that part in there, now we could go in and start adding dimensions for that part. Now, just like we showed earlier, we could come over here to the properties of the sheet, right click, go to properties, and we could change the scale, maybe make this like 1 to 12. 1 to 12. Make this a little bit bigger, make it a little easier to see what our dimensions are pointing to. And then we could add in some of those dimensions. We could add in a dimension here for the max width. We could add in a dimension here for the max height. We could add in a dimension here for the wall thickness. And then we could add in some dimensions to help locate the handle. So we could add in a dimension here for the handle, add in a dimension here for the handle. Okay, this isn't necessarily going to match to a standard, but it's going to give our manufacturing team the information they need to kind of cut this out of wood and create a prototype of this thing. So we could add in some dimensions here, add in some dimensions here, and that should be enough to give them what they need. Of course, we'd want to call out the fillets and things like that too, but we're going to kind of leave it at that for now. The other thing that I mentioned earlier is that when you're looking at the title block, you can link these notes to certain properties. So for example, if I double click on this note here, and then I double click again to kind of highlight the note, we've got this option here for link to a property from the drawing, and also this property here for link to the item, the drawing or the model that's included in the sheet reference property, which is usually that's the first drawing view on the sheet. So if I click on that option there, then I could link to something like description, And you see that gives you the description of that part. Or I could even link to the part name. So if I choose name here, you see that shows me the main wall because that was the name of the part in the PartStudio. If I change the name in the PartStudio, it's going to update here automatically on the drawing. And it's usually a good idea to create those types of links so that if you do change it in one place, it updates elsewhere. So really cool that you can link to properties that'll update dynamically. And of course, you could also just make that static text if that's what you prefer. You could double click on it and just change the value of the text. So that gives us a nice 2D drawing. We could print this 2D drawing, print it on our 2D printer, and then we could take this with us out to the shop and we could actually cut this thing and make sure that we've got the dimensions correct. If we go back to our first sheet here, so I double click on the first sheet, we can see here that the information that we need for the rear brace is pretty much all there. I mean, maybe we could add in some dimensions to give us everything that we need for that as well. So we could add in a dimension here for the thickness of that rear brace. And we could add in a dimension here for the height of that rear brace or the thickness in the other direction. So now we've got all the dimensions we need for that rear brace, but we do have the information for the leg that still needs to be mapped out. And what I did with this leg is I actually created a one-to-one template. So this is just out of paper here. Okay, and by taking these different sheets of paper and taping them together, I was able to create a one-to-one template, and that way I can lay this over top of the wood, and then I can actually cut this thing out of the wood. So to accomplish something like that, what we could do is we could go here to add sheet. So we're going to add another sheet here. Maybe I'll go to the main wall and then I'll choose to add a new sheet. And then what we could do is we could just get rid of everything that's here on the title block, leaving us with this empty sheet. And then what we could do is choose to insert a view. And when we go to insert a view here, we're going to click insert and we're going to go here to the leg and then we're going to insert a right side view. So a right side view of the leg there, and then we'll just take that out and drop that on that sheet. And there we go. There is the leg. We can press escape because we just want that one single view. And now we can go over here to the name of the sheet. So it says sheet 1 currently. We could press shift N. We could rename that. Let's call it 002-leg. So that's our sheet for the leg. And then when we come here to the leg, what we could do is we could go to the properties of that sheet. So we right click here on the name of the sheet. We go to properties and we're going to name this, we're going to call this a scale of 1-to-1. So we make that a scale of 1-to-1 there, and there we go. There is that leg. Now we can move this onto the sheet as best we can, and then we can come over here to the name of the sheet, and we can right-click, and we can choose duplicate. So if we do that 3 times, if we duplicate that sheet again, so right-click, duplicate, and right-click, duplicate. Now we've got these 4 copies of this leg all at 1-to-1. And so we could go here to this first copy. This is the one that we kind of put in the lower right corner. We could go here to the second copy, or maybe this is the first copy. We go here to this next 1-to-1 sheet of this leg. We can move the leg here. We go here to the third copy, this 1-to-1 copy of the leg here, move this over here, and then we go to this 4th copy, this 1-to-1 copy of the leg, and we move it over here. And there we go. That gives us a nice bundle of drawings that can now be printed. And when we go to print these, we could print this at a 1-to-1 scale. So that kind of brings me into the final topic of this video, which is to create that bundle of drawings. And so when it comes to exporting that bundle of drawings, what we could do here is we could come up to this option for the hamburger menu in Onshape. And once we click on that option, we can choose print. And when you choose print here, what happens is by default, it automatically kicks off a PDF of that drawings bundle. So you've got sheet 1, sheet 2, sheet 3, sheet 4, sheet 5, and sheet 6 here. Now, if you just wanted to turn that into a PDF and send it around to your team and view it on a tablet, something like that, you could choose the download option here, and that's going to download a copy of that PDF. But if you did want to make a print of this thing, you've also got the option to print here. And when you go to create that print, you've got some options down at the bottom here, like what is the scale going to be? We're going to make the scale custom at 100%, at 1-to-1. And then we're going to print that thing out at 1-to-1. And that way we can take those 4 sheets and we can cut them up and tape them together. You know, we take some measurements off these things as we're making them. We make sure that that distance is truly 3 inches, you know, kind of double check yourself. I like to throw additional dimensions on there. I know they're kind of hard to see, but I've got a dimension on here at 19.5 so that I can measure this thing after I tape it together and make sure that I am getting 1-to-1. But it worked out great. You know, this is exactly what I did when I made the physical copy of the Rebounder, the physical prototype, and it worked out great. And so that does it for exporting that bundle of drawings. And you guys can give that a try. You can give that a printout, and that should give you what you need from that bundle of drawings for this project. And so the final thing that I might do here is just do a little bit of a final cleanup, some final data management. Maybe I would go back to the PartStudio. So this very first tab here, the wood parts, the PartStudio, and I would go through the tree and just kind of make sure that everything is renamed properly. You want to make sure that it's easy to navigate this project later on. I would also do a little bit of validation with my variable studio. So I would go here to the assembly, and then looking at the variable studio, I would go through and just make kind of some range changes, like the max we think this thing is going to be is 60. And does that still look okay? If it's at 60, the max height that we're going to have here is going to be 30. Does it still look okay if we make it 30? Do the legs still open and close? We can unsuppress that extra leg and test that. And then the min is going to be 36 for the width. And then the min for the height here is going to be 12 inches. So if we change it to the min, does it work? In this case, it doesn't. Look, changing it to 12 caused an error. So maybe I need to go back and take a look at what's causing that error. What if we made this 14? Does it still error? Okay, the legs come back there at 14. So it looks like it's probably an error with that offset distance, an offset of 3. You know, once I went too short, I wasn't able to make that offset of 3. And so that's the kind of validation that you want to do before you officially release this thing. And then once you're satisfied with that, once you're satisfied with the height that you've selected, with the width that you've selected, and you know, another thing you want to do when you're doing that is also look at this thing in the drawing. So if I increase the width here, let's say to 54, and then I increase the height to 22, what does that look like in the drawing? So we'll go back to the drawing and we'll see, you know, how that looks in the drawing. Oh, it looks the same. Doesn't look like anything changed. Well, we've got this button here that we can click to update everything from the assembly workspace. So we click on that button, let everything update, and then we can kind of look over it and say, yeah, it still looks pretty good. All those dimensions look like they updated. The views all look like they updated. I'm happy. I'm happy with this validation. So we go back to the assembly. Let's put some of these values back to what they were. Change this back to 48. Change this back to 18. Again, go through and update anything that needs to be renamed, update all the properties and everything. And then the final thing you want to do is just come over here to what we call versions. We want to go over here to our versions here, and we want to create a new version. Okay, so we've got our versions in history here, and we want to make sure that we create a new version. So create a new version. We could call this V1. We could say created drawings bundle and tested at different sizes. And we can say create. And there we go. We've created a version. A version is like a snapshot in time. This version, version 1, can never be changed. Okay, you can never change version 1. You can make changes to the main workspace. So I could come over here now and I could say I'm going to make one that is 54 by 22. So there we go. Make one that's a little bit larger. And then we could create a new version that is 54 by 22. So I could click here. I could say create version. This is going to be called V2, made larger. And we'll call this 54 by 22. All right. And we're going to create that version. And now what's really cool is at any point I could go and I could look at V2, or I could go and I could look at V1. So it's like I've created a snapshot of the project in that state, but V1 can never be changed. V2 can never be changed. What I can do is I can work on the main workspace and I can make changes moving forward. Then I can make a new version, but that state of the model in V2 is immutable, and we'll never be able to change that. And that's kind of cool. It helps you with document control. It helps you and your team to make sure that you're always working on the expected version of the project. And with that, that is pretty much going to be a wrap for this project. Let me know down below in the comments what you thought about this tutorial. You can see behind me, I've got the physical rebounder behind me. One of the best things we can do as engineers is take an idea from our brain, turn it into a prototype in Onshape, and then turn it into a physical project and actually see how it all works. And I gotta say, this one worked great. So if you're out there, if you've got a friend, a niece, a nephew, a relative who's looking for a gift for the upcoming holiday season or anything like that, this is a great one to build. It does take some time, it does take some TLC, but it is a really fun project to work on. But we covered a lot of really good information about how to go from idea to physical prototype. We talked about how to start out your project, how to create a variable studio to kind of map out your key dimensions for the project, how to make a PartStudio and insert the first couple of components, how to take that and add it to an assembly, how to create some motion in that assembly so that you can test out your motion ranges for your prototype. And then we started talking about how to take those components and add them to a drawing, how to make some of the different drawing views, how to change the scale of our views, change the scale of our sheets, change the display of our views, and how to add multiple sheets. And when we do add those multiple sheets, how to actually create drawing views of the individual components so that when you're done, you could end up with a physical booklet of drawings, and then you can take this with you to the hardware store to pick up the lumber to make sure you've got all the components that you need for your project. So I really hope you guys have enjoyed this tutorial. Let me know down below in the comments what your favorite part was. Let me know if you have any questions. And of course, be sure to like, be sure to subscribe, and be sure to come back for the next Onshape step-by-step tutorial.